Hello people, welcome one and all to Jojo's Learning Club.
Hello guys, welcome back to my channel. So this is the part 2 on the exercise 2.1. On my previous video, I've explained about the solutions for the exercise 2.1, the question number 1 to 5. And on this video, we'll discuss the further work problems. Okay, so let's directly go with the sixth problem. If A cross B is given as AX, AY, BX, BY, find A and B. So to do this problem, you already know the definition of Cartesian product of two non-empty sets. How it is given? So if, for example, let's say there are two non-empty sets P and Q, then we can write the Cartesian product of two sets P cross Q is given by set of elements PQ, set of all ordered pairs PQ, where the small p belongs to the capital P set P and the Q, the element belongs to the set Q, that is the set of all ordered pairs. So you can say that the set of all the first elements are the elements of the set A. So what are the elements of set A? A and B. And again, set of all second elements of the ordered pair are the elements of the set B. So what are they? X and Y. And hence we have found the what are the elements of A and B. That's all for the sixth problem. And now let's move on to the next problem. Let A is equal to 1, 2, B is equal to 1, 2, 3, 4, C is equal to 5, 6, and D is equal to 5, 6, 7, 8. So verify that. We have two sub-problems in it. The first problem is that we have to prove that A cross of B intersection C is same as A cross B intersection A cross C. So for that, to do the first problem, I'm going to start by LHS. What is LHS given by? A cross B intersection C, right? So A cross B intersection C, first it would be easy if you could find B intersection C and then find the Cartesian product. So what is B intersection C? Are there any common elements between B and C? Can you see any common elements? There are no common elements, right? So B intersection C is what? It is a empty set of phi. So A cross phi is again what? Phi itself. Okay, so now we have found the LHS. Now we have to find that RHS of the equation. So R is the RHS given as A cross B intersection A cross C. So let's find what is A cross B. A cross B is the set of all elements of set of all ordered pairs, right? So what are they? 1, 1, 1, 2, 1, 3, 1, 4. Again what again? 2, 1, 2, 2, 2, 3, 2, 4, right? Again now let's find the set of all ordered pairs of A cross C. What are they? 1, 5, 1, 6, 2, 5 and 2, 6. Can you find any common elements? Say intersection means there are set of all common elements, right? So there are no common elements between these two Cartesian products, and hence you can say that A cross B intersection A cross C is phi. That is, it is an empty set. There are no elements in it. Okay, hence we have proved that the LHS is same as the RHS. Okay, so we have solved the first section of the problem, and the next section is that A cross C is a subset of B cross D. So by the second one, we have to prove that the Cartesian product A cross C is a subset of the Cartesian product B cross D. For that, A cross C we have already found, right? Now we have to find what is B cross D. Let's find what is B cross D. B cross D is what? What a set of all possible elements, right? So what are the elements? 1, 5, 1, 6, 1, 7, 1, 8, again 2, 5, 2, 6, 2, 7, 2, 8, next again 3, 5, 3, 6, 3, 7, 3, 8, and next again 4, 5, 4, 6, next again 4, 7, 4, 8. So Now let's take the intersection. Intersection is what? Are there any common elements? For example, it is at a, sorry, not intersection, it is at a subset. So subset means all these elements of A cross C should be also be included in B cross D. Let's check that first. You can see that 1 comma 1 comma 5, so that is already there. Again 1 comma 6, that is also there in this set. Again 2 comma 5, that is also there in this set, and 2 comma 6. Hence we can say that A cross C is a subset of the Cartesian product B cross D, and hence we have proved the both the sub problems in this question. So now let's directly move on to the next question. If A is equal to 1 2 and B is equal to 3 4, write A cross B. How many subsets will A cross B have? List them. So let's do the first part of the question to find the Cartesian product of A and B, that is A cross B. So let's find out what is it. 1 3 2 4, again 2 3 2 4. So these are the elements of Cartesian product A and B, right? So now let's find how many subsets will A cross B have. So to find the number of subsets, we have to know about the chapter 1 sets, about the power set. What is a power set? Power set is the set of all subsets. So power set is what? Actually the set of all subsets. Okay, now let's consider that there is a set A and the number of elements of the set is B, then the total number of elements in the power set will be n of P of A is equal to 2 raised to B. Okay, so this is already given in the chapter sets. Please refer to the chapter sets if you have any doubts on this. So now we have here now we have to find the number of number of all power sets. So P of A cross B, we already know the count of it. What is this? 2 raised to 4, right? So what is 2 raised to 4? It is 16. So there are 16 number of elements in this set. Now let's find which are these subsets. So we have found the number of elements of A cross B, and also we have found the number of all subsets. That is what? 16 possible subsets are possible. So what are the possible subsets? 5, that is an empty set which is always there, which is always a subset of every set. Again, what are the possible sets? Again 1 3, right? Again next one 1 4 separately, again 2 3, again 2 4, again. What are the possibilities? 1 3 and 1 4. The next possibility would be what? Again 1 3 and 2 3, and then again the next possibility 1 3 and 2 4, right? And again 2 3 and 2 4, and again the next possibility 1 3 1 4 2 3, again 1 3 1 4 and 2 4. The next one 1 3 2 3 and 2 4. The next one 1 4 2 3 2 4, and the final one 1 3 1 4 2 3 and 2 4. So that's the answer for the question number 8, and now let's directly move to the next question. So let's now do the ninth problem. Let A and B be two sets such that n of A is equal to 3 and n of B is equal to 2. If x comma 1, y comma 2, z comma 1 are in A cross B, find A and B where x, y and z are distinct elements. So we have to find the elements of A and B, and now some of the elements are given of A cross B. So we know that what is a Cartesian product of two sets? So if there are two non-empty sets A and B, this in the set of all ordered pairs x, y, where x belongs to A and y belongs to B is called the Cartesian product of A and B. So let's write it. What is the Cartesian product of two sets? A cross B is given by set of all x, y, where x belongs to A and y belongs to B. Right? So this is what a Cartesian product of Cartesian product of two sets A and B. Now let's find if x, y are the sum of the elements are given. What are they? X comma 1, y comma z, y comma 2 and z comma 1. Right. And it is also said that number of elements of A is what? 3 is given. And the number of elements of B is given as 2. So it is like a hint for the problem. Also, we know that all the elements of the first elements of the ordered pairs are the elements of the set A. So what are the elements? X, Y, Z are the elements of the set A. And also we know that the set of all second pairs of the ordered pairs are the elements of the set B. So 1 and 2. So we have already found, it is already given in the question that there are two elements in B and there are three elements in A. So the elements of A are X, Y and Z, and the elements of B is 1 and 2 are 1 and 2. So that's all for the problem number 9. So now let's discuss the 10th problem. The Cartesian product A cross A has 9 elements, among which are found minus 1, 0 and 0, 1. Find the set A and the remaining elements of A cross A. So we already know that if there are number of elements of two Cartesian products, two sets A and B is given by n of A cross B is given by n of A into n of B. In this case, it would be what? N of A cross A, and it is already given that it is 9, which is equal to what? N of A into n of A. From this, we could easily find the number of elements of A. What are they? There are 3 elements. So, and also in the question, there are 2 elements of already these 9 elements already given, which are they? Minus 1, 0 and 0 and 1. Also, we know that A cross A is what? Set of all ordered pairs A comma A, where A belongs to A, right? So therefore we can write that minus 1, 0 and 1 are the elements of set A, right? So we can now easily find the remaining elements of A. What are the possible remaining elements? Minus 1 and minus 1, again minus 1 and 1, again 0 and minus 1, 0 comma 0, 1 comma minus 1, 1 comma 0 and 1 comma 1. So these are all the 9 elements of the Cartesian product A cross A. With this, we come to an end on the section exercise 2.1. On my next video, we'll be covering up the exercise 2.2. So let's see you over there. Bye bye. See you then.